Hello, and welcome to the My Health Navigator project video. My name is Brandon Crone, and I am the team lead for project number 23038. The My Health Navigator project has been sponsored by Dr. Aaron Rao and Dr. Lacey Rao, as well as mentored by Dr. Elmer Gross. Our team consists of 2 electrical computer engineers, being Dylan Edson and Jerome Klosterman, 2 system engineers, being Nathan Owens and Isabella Martinez, who is also our procurement lead, as well as 2 biomedical engineers, being Lauren Melosh and myself included. Essentially, the My Health Navigator team was tasked with developing a software proof of concept for an inpatient hospital website application. This application incorporates 3 distinct views: a patient view, a doctor view, and an admin view. In summary, information that will be shared directly to the patient's electronic device will be pertaining to their assigned care team members, any upcoming events, as well as any rounding alerts that have been sent by their physician via the doctor view of the application. These applicational functionalities are supported by the admin view. This is where all accounts are created, patients are assigned their healthcare team, and where scheduling of events occurs. All views have been tested by the design team on 6 different browsers, as well as various devices such as computers, tablets, and mobile devices. The goal of the My Health Navigator project is to help patients better navigate their inpatient hospital experience. The website addresses the core problem of outdated communication techniques seen between the healthcare staff and patients. A large percentage of admitted hospital patients are senior citizens, and therefore we as a team have tailored our patient view to emphasize simplistic features while simultaneously providing pertinent information. Furthermore, test simplicity and efficiency was a main priority during development in order to minimize the time doctors have to spend on the application rather than with their patients and colleagues. Ultimately, the My Health Navigator application aims to increase overall trust between patients and healthcare providers, reduce patient anxiety, improve patient health outcomes and overall experience, as well as increase funding to the healthcare system.
The first steps to our project included performing research and ensuring that we were working towards meeting all engineering standards applicable to our system. Throughout the development process, some of these standards that we want to highlight include internet standards such as Hypertext Transfer Protocol. These are a set of rules for transferring files which allow for consistent communication. Since the purpose of our application is to be used in a clinical setting, we also wanted to highlight research and security standards. These include HIPAA compliance upheld by hospitals and the advanced encryption standard. In order for security certification to be granted, these pages must utilize this standard. All research performed and standards include how our system would be engineered.
The start of any rigid engineering design process is understanding stakeholder needs. We met at length with our sponsors to ensure we could create an application with functionality that meets the needs of doctors and patients. These needs became our functional and system requirements. As can be seen, our requirements capture everything from security processes to page design and functionality. Our detailed design was made specifically to meet these requirements. As can be seen in our system block diagram, all critical elements of our software system are represented. To dive deeper into our design, we can see the specifics of the admin view in the system block diagram. This was our source of truth for all following design artifacts and provides the best overview of what the system looks like. Let's further use the admin view to illustrate the detailed design process we applied to the entire system. For each subsystem of the application, we created GUI mockups to show the expected page layouts, class diagrams, which specify by page the operations and attributes associated with each component, use cases, which detail all functional uses within the system by their inputs and outputs, and activity diagrams, which consist of all activities taking place within specific pages and a logical flow between them. Now let us address how we turned these designs into reality.
After a few stumbling blocks in the first semester, we took on the second semester using Agile development. As Scrum Master, I would design tasks, assign them velocity values, and then assign them to members of the team. Tasks were split between bureaucracy and software. Most design documents were finalized in the first semester, so tasks could reference specific files that needed to be created or integrated: HTML for patient homepage, create account.js for admin, etc. Splitting development this way smoothed out our communication and progress tracking. Testing and testing requirements also came into focus as a software task completed a test and describing how to validate it was created and passed on to other team members. This is how we built the app progressively. App development progressed from Replit to the AWS server to a final encrypted server provided by Liquid Web. Replit is a collaborative browser-based compiler which allowed the ECE team to test front-end code without risk. Pages would be designed in Replit, then developed on the Amazon Web Services server to be tested with a test database. Once we've assessed the code worked as expected with the AWS server, approved files were moved to the Liquid Web server.
As engineers in the making, naturally we were faced with obstacles throughout the past year. These include organization, where we quickly learned that the design waterfall methodology was difficult to apply to our particular system. We were able to overcome this by switching to Scrum management. Next, a communication barrier, where one of our team members was living overseas in Japan during this past year. We learned to navigate this by considering differences in time zones and managing continuous communication. Security, where we lifted the complexity of aspect of our system utilizing a liquid web server. This is a HIPAA-compliant server where our software developers no longer had to spend extensive time on the specific server security. And finally, the size and scope. We started the project naive of the complexity of the task given to us. With outside consulting, we were able to overcome this by scaling back our project to a realistic size given our resources and time.
When the switch to Scrum was made, this changed how we verified our system. Aspects of the application were being verified as the system was being developed, and feedback from the team drove development. Using the created test cards, the team would test various functional and structural aspects of the application rather than entire system requirements. Feedback was given to the development team to be implemented and tested again in later sprints. For example, in Sprint 2, we looked at the user interface for adding care team members and events. After first verifying this interface, the application functionality of adding doctors and events to a certain patient was tested in Sprint 5. This process allowed us to verify the functionality of our system components, and we later used these results to create the final verification plan for how we would verify each system requirement. Because our system doesn't use mathematical models or analysis, many requirements were verified using demonstration or testing. Using this verification plan, we created the margins for which we would consider each system requirement a pass.
Our final acceptance test procedures were developed as a sort of checklist, so to speak, that can be moved through linearly. Because of the iterative nature of the application, I'll show some of the applicational usage and requirements being tested, including account, entities, admin view, patient view, and search. In the admin view, I can create a patient account, which I'm doing right now, as well as a doctor account. Afterwards, I can search the patient, Stephen, within the admin homepage and click on this entity. I can edit the floor numbers as well as search for the created doctor, Isabel Stevens, under Care Team. When I click on this entity, I can then add them to their care team, as you can see when the page is refreshed. Moving to patient, I can log into the created patient, Stephen, with the credentials used. And when you click under Care Team, Isabel Stevens populates.
A proof of concept is a key step to full development, as bringing a software project of this size to bear would require thousands of dollars in personnel hours. Verification of our system proves our proof of concept is fully functional. This performance can then be shown to the project stakeholders to better inform their decision for full application development.
To conclude our video, this application's purpose is to create a shift towards increasing healthcare efficiency while also improving patient comfort. Through this proof of concept, we aim to demonstrate the revolutionary potential impact that the application can have on day-to-day healthcare. Thank you for listening, and we cannot wait to show you how far we have come on the development of our project during Design Day.